Astrophysics, Exploring the Universe Through Physics and Mathematics. Title: Astrophysics, Exploring the Universe Through Physics and Mathematics. By using a combination of physics and mathematics, astrophysicists explore the depths of space, uncovering cosmic phenomena and unlocking the secrets of the cosmos. This article will provide an overview of the field, its methodologies, and how astrophysics contributes to our understanding of the universe. The basics of astrophysics. Astrophysics combines the principles of astronomy and physics to study the behavior, properties, and interactions of celestial bodies. It aims to explain the nature of the universe and its components. From galaxies and stars to planets and beyond. Observational astronomy. Observation is a fundamental aspect of astrophysics. Using powerful telescopes on Earth or in space, astronomers gather data and capture images from various parts of the electromagnetic spectrum. By studying this data, astrophysicists can gather insights into stellar life cycle, galaxy formation, and even the existence of black holes. Observational astronomy serves as the basis for numerous ground-breaking discoveries in the field. The role of physics. Physics serves as the backbone of astrophysics, providing the foundational principles that drive our understanding of the universe. One of the key concepts utilized in astrophysics is gravity. Sirius. Isaac Newton's laws of gravitation allow astrophysicists to explain the motion and interaction of celestial bodies. Understanding gravity is pivotal in deciphering the physics behind planetary orbits, galactic structure, and the formation of star systems. Quantum mechanics, another important branch of physics, also plays a role in astrophysics. These quantum-based investigations aim to unravel the mysteries behind the expansion of the universe and the unseen forces shaping its existence. Beyond the laws of classical physics and quantum mechanics, astrophysicists also employ other areas of study. Thermodynamics helps explain the energy transfer within stars, while electromagnetism offers insights into the behavior of cosmic particles and radiation. Additionally, astrophysicists utilize atomic and nuclear physics to comprehend the formation of elements in stellar interiors and the energy processes of celestial phenomena like supernovae. The power of mathematics. Mathematics is the language of astrophysics, enabling scientists to quantify observations and test theoretical models. Astrophysicists use mathematics to describe celestial motion, calculate distance, and predict cosmic events. Equations like the Doppler formula allow scientists to determine the speed and direction of galaxies, while statistical models enable us to estimate the likelihood of, say, routine celestial occurrences. Mathematical models help astrophysicists gain insights into complex phenomena such as the evolution of stars and the formation of galaxies. By applying numerical simulations, scientists can reproduce physical systems and study them in detail. These models are crucial in understanding the behavior of cosmic objects over vast timescales and distances, enabling scientists to make predictions and test hypotheses. Astrophysics and practical applications. Astrophysics not only contributes to our understanding of the universe but also has practical applications in our everyday lives. For instance, research on cosmology and the expansion of the universe has led to the development of precise GPS systems that we now rely on for navigation. Additionally, studying space weather, which is influenced by solar activity, helps safeguard our communication and networks and power grids from potential disruptions. Astrophysics is an ever-evolving field that constantly challenges our understanding of the universe. These cutting-edge instruments provide unprecedented views of distant galaxies, allowing scientists to study their formation and evolution. By studying the composition and geological history of other worlds, astrophysicists can better understand the conditions necessary for life to arise and persist. In addition to its impact on our understanding of the universe, astrophysics also contributes to technological advancements here on Earth. For example, the development of space-based telescopes has led to improvements in optical and imaging technologies that are now used in medical imaging devices, such as CT scans and MRI machines. The precise control of spacecraft and the navigation systems in space missions have also influenced autonomous vehicle technology and robotics. Astrophysics has also played a role in fostering interdisciplinary collaborations. Through partnerships with engineers, computer scientists, and researchers from other scientific disciplines, astrophysicists are able to tackle complex problems with innovative solutions. This multidisciplinary approach has led to breakthroughs in fields such as data analysis, machine learning, and supercomputing. As we look towards the future, the study of astrophysics holds great promise for further expanding our understanding of the universe. The development of next-generation telescopes, such as the James Webb Space Telescope, will allow scientists to observe even further into space and study the mysteries of the early universe. The field is also actively exploring new areas of research, such as gravitational waves and exoplanets, which are expected to yield groundbreaking discoveries in the coming years. Astrophysics has always been an intriguing and captivating field of study for those who wonder about the mysteries of the universe. By utilizing the principles of physics and mathematics, astrophysics is to explore the depths of space and uncover cosmic phenomena, shedding light on the secrets that lie beyond our comprehension. The field of astrophysics combines the realms of astronomy and physics to study and understand the behavior, properties, and interactions of celestial bodies. It aims to explain the nature of the universe and its various components, from galaxies and stars to planets and everything in between. Observation plays an instrumental role in astrophysics. Astronomers employ powerful telescopes, both on Earth and in space, to gather data and capture images from different parts of the electromagnetic spectrum. By studying this data, astrophysicists can gain valuable insight into the life cycle of stars, the formation of galaxies, and even the existence of enigmatic celestial bodies like black holes. Some of the most groundbreaking discoveries in the field have been made through observational astronomy. Physics serves as the foundation of astrophysics, providing the underlying principles that drive our comprehension of the universe. One of the key concepts utilized in astrophysics is gravity, as explained by Sir Isaac Newton's laws of gravitation. It allows astrophysicists to elucidate the motion and interaction of celestial bodies, providing critical insights into planetary orbits, galactic structure, and the formation of star systems. Quantum mechanics, a crucial branch of physics, also plays a significant role in astrophysics. These investigations aim to unravel the enigmatic forces that shape the expansion and existence of our universe. In addition to classical physics and quantum mechanics, astrophysicists also employ other areas of study to further their understanding. Thermodynamics helps elucidate the energy transfer that occurs within stars, while electromagnetism offers insights into the behavior of cosmic particles and radiation. Moreover, atomic and nuclear physics aid in comprehending the formation of elements in stellar interiors and the energy processes associated with celestial phenomena such as supernovae. Mathematics serves as the language of astrophysics, allowing scientists to quantify their observations and test theoretical models. Astrophysicists utilize mathematics to describe celestial motion, see calculate distances, and predict cosmic events. Mathematical models enable astrophysicists to gain insight into complex phenomena like star evolution and galaxy formation. By utilizing numerical simulations, scientists can recreate physical systems